My name is Jamie Sullivan, and I am the manager for the Safety Center. It looks like we have about 30% of you coming from both the Midwest and the Western U.S., about 21% coming from the Southeast, about 11% from the Northeast, and 8% from other. So we're glad to have all of you with us today. It does look like we have about 82% of you using computer only. I do want to remind everyone that if you do have any audio concerns today, if you could please dial in, and you can find that phone number in the top left-hand corner of your screen. A lot of the times when you are joining us by computer only, there may be some audio issues, and calling in will help with that. It does look like we have about 24% of you from state DOTs, about 15% from federal DOT, 22% from local transportation departments. We have about 5% from other federal, state, or local agency, about 7% of you from educational institutions, and about 27% of you who are private consultants. And then it does look like we have most of you, about 80%, joining us by yourself, but as always, we do have a few of you in groups. Once again, we'll remind you to please send those group lists in so that we can make sure we get the survey out to you, as the survey is the way you would request your certificates of completion and CEUs, and I'll provide you with that information here in a second. I'm going to move us over to our presentation and give you just a few more logistics. So today's webinar is an hour-and-a-half long. It is being recorded and will be archived on our website. For quality of this recording, we have muted you during the presentation. If you are listening on the phone, we would ask you to please mute your computer as well. To maximize the presentation, when we do show videos or if there are graphics you'd like to see bigger, you can use the 4 arrow keys that press outward, and they are located in the top right-hand corner of your screen right now. That will get rid of all of the stuff on the outside. At the end of each section, we will have time for question and answers. There is also a handout pod that you can find in the bottom left-hand corner of your screen. You can download a copy of today's presentation in PDF format. This will also be available when we do post this to our website as well, but just in case there are any resources that you're interested in having and don't want to write those down, you can download that handout. Again, it's in the bottom left-hand corner. Any groups, please send your list with name and email addresses to info@ruralsafetycenter.org. This will allow us to send you the survey following today's webinar. That is, again, the way that you'll request CEUs and certificates of completion. And again, please do complete those follow-up surveys. There will be the one that does follow today's webinar, as well as one that will come out in about 3 months. That one in 3 months will ask you questions about how you use this information, if you put any of it into practice, if you shared it with any coworkers. And the survey link, just in case that survey that we send you in a little while does go into your junk mail, we did put the link right here in the webinar as well. Again, it's also in that handout in the bottom left-hand corner. The survey closes about 2 weeks after the webinar, so you can expect the CEU and certificate forms somewhere between 3 and 4 weeks after the webinar. The CEU forms, you guys will need to fill out and send them back to continuinged@montana.edu and not to the Safety Center. Also, if you would like proof that you have received those CEUs, you can send them an email and request a verification of completion form, which I'll show you here on this next slide. That form in the bottom right-hand corner is the verification form, and this will show any CEUs that you have earned through the Safety Center, including if you attended our summit 2 weeks ago or the summit 2 years ago as well. So all CEUs for those would show up as well. And then the course registration form is the one in the top left-hand corner. As always, the CEUs are free through the Safety Center, so you do not need to pay for those. Today's webinar is being co-hosted by Federal Highway Administration and the Everyday Counts 5 program, by NACE, the National Association of County Engineers, and by the National LTAP and TTAP Associations. We'd like to thank all of them for co-hosting as well. For today's presenters, we do have Keith Knapp, who is from Iowa LTAP, and Dick Albin from FHWA. I'm going to provide you with some bio information for both of them. Keith is the director of the Iowa Local Technical Assistance Program at the Institute for Transportation at Iowa State University. He has more than 25 years of experience in transportation-related training, outreach, extension, and research. He has developed and been an instructor in local, state, and national training courses with a wide range of subjects and has taught traffic engineering, safety, and highway design at various universities. He is a registered professional engineer, and we're proud to say that he's also a part of the Safety Center's team. Dick Albin joined FHWA as a safety engineer with the FHWA Resource Center's Safety and Design team in June 2008. Prior to joining FHWA, Dick worked for 15 years with the Washington State Department of Transportation and was an assistant state design engineer when he left. Dick also worked for 6 years for the New York State Department of Transportation in a regional office. He graduated from the University of Wyoming with a BS in Civil Engineering and is a licensed professional engineer in Washington State. Dick is a certified NHI instructor. So the goals for today's webinar: once you have completed this webinar, you will learn about clear zone treatments and crash testing of roadside hardware. To achieve the webinar goal, you will learn to define clear zone, its basis and limitations, describe critical, traversable, and recoverable slopes, list the methods to reduce the potential to crash when a vehicle leaves the roadway, identify the criteria for determining the crash worthiness of roadside hardware, describe the implementation plan for MASH, and identify hardware that has been tested to MASH. And so Keith will be going through the first 3 of these learning outcomes, and Dick will do the second 3. And at this time, I am going to turn the presentation over to Keith Knapp to get us started. Keith?
Thank you, Jamie. Welcome, everybody. Good morning or good afternoon, as the case may be. Each time we do this at 12 o'clock Midwest time, Central time, never quite sure where people are in the day. So as Jamie mentioned, my name is Keith Knapp. I'm with the Iowa LTAP. Been a researcher, teacher, consultant, instructor for quite some time. And as she mentioned, this is the 3rd part of a 3-part series in which we've talked about rural roadway departure countermeasures. The first one if you were with us, talked about kind of the Everyday Accounts program and why they're focusing on rural roadway departures along with rumble strips. And the second one had high friction surface treatments and curve delineation, or a delineation, I should say. So this one is about, again, essentially roadsides. I'll be talking about some methods to reduce some of the potential. Dick will be talking about the shielding part, the barrier part. Before we jump into it all, I did want to talk a bit about why we're focused on rural roadway departure. And as you can see from this slide, the average between 2014 and 2016, annual average in the U.S. was about 35,230 fatalities, of which half of approximately of that was rural, and about 30%, 34% was actually rural roadway departures. And you can see the federal highway definition of what a rural roadway departure is, which is why we also talked about rumble strips and things like that. It's basically people leaving the traveled way to the left, to the right, essentially leaving their lane. Now, there are 3 objectives that we can use, 3 ways we can kind of approach this problem, and you'll see this slide a couple of times today. One, of course, is to keep vehicles on the road. We talked about rumble strips. That was kind of in that first part as a strategy. You can reduce the potential for crashes, and I'll show you on the next slide again some of those, and that's kind of what I'll be talking about, is some of those strategies today with regard to clear zones and whatnot. And again, Dick will get into minimizing the severity, the shielding part. So some of the strategies that we have here to reduce the potential of crashes, and there are more than this, and we'll talk about some of those. We'll talk about these and some others. One, of course, is the safety edge, which we'll talk about today, clear zone, and then the traversable roadside slope. So I should just, the pictures here, safety edge, and of course your clear zone and your traversable roadside slope there, at least kind of an example of that. And of course, with the minimizing the severity part, we get into the barriers, signposts, breakaway, utility poles. I have one slide on signs and the fact that for many, many years, signposts and other posts actually are required to be breakaway if they're within the clear zone, at least per the MUTCD for a long time. So three outcomes for my part. You should be able to define the clear zone and its basis and limitations, describe or, if you will, define critical, traversable, and recoverable slopes, and then again throughout as the presentation. So there's kind of three parts to my presentation, but the methods one kind of is throughout the entire part. So here's the clear zone. Here's the definition of a clear zone. If you don't have the Roadside Design Guide and you're interested in roadside safety, you should purchase the Roadside Design Guide. It's an AASHTO document that was done in 2011. And again, the definition is an unobstructed traversable area provided beyond the edge of the through traveled way for the recovery of errant vehicles. And that edge of travel way starts right at that edge line. So we'll be talking about everything outside that edge line, shoulders, safety edge, and whatnot. But if you want more information, more detail, I will be referring to the Roadside Design Guide multiple times in slides. Lots and lots of detail that you're not going to get here today that you can get in the Roadside Design Guide. The origins of the clear zone, and a lot of people kind of may or may not know this. I believe it was in the 60s that GM basically looked at 10 years of their crash data on their test track. So they had people going around in circles. I'm assuming the test track was circles. I probably shouldn't make that assumption. But they had people driving this, test drivers, and they sometimes left that roadway. And for 211 cases over a decade, they basically found that 40% of those stopped or recovered within 10 feet. 80% stopped or recovered, about 30 feet out or within 30 feet. And then about 90% stopped or recovered within 50 feet. And so what happened was AASHTO, and it's kind of on the next slide, picked that 30 feet and kind of used that for a while. And this was a significant thought process, too, that went on with regard to roadsides. Because previous to this, it was people leave the roadway, they've made a mistake, it's kind of up to them. At some point, someone said, no, they should be able to make some errors, and we should be able to recover and essentially live and not get hurt. They should be able to get back on the roadway if possible, or at least survive a crash. So they ended up, again, on this test track, actually going all the way out and putting 100-foot clear zones in. But AASHTO basically picked the 30-foot clear zone. They adopted that, and then somewhere in the 70s, they started doing some adjustments. So this table you see here is actually from the Roadside Design Guide and shows you that there are a number of factors that are taken into account when you talk about clear zone. And remember the definition of that, a clear, traversable area. And so you see that they are related to your design speed. This is a design table. Essentially, you have design clear zones, and then you have what's actually out there if you've got a roadway. Design speed, design average daily traffic, and then your foreslope or your back slope sloping is the best way I could put it. Now, I did want to point out on this slide that if you do have the Roadside Design Guide, this is actually the slide from the guide, but in 2015, and I realized this morning, didn't get a chance to change this table, 3 cells on this table had an addendum or a errata that changed this table. So the upper right, if you go across from the lower than 40 miles an hour and go over to the last 3 columns, those last 3 rows and those last 3 columns, just in those top 3 cells, have changed to essentially from 10 to 12, 12 to 14, and 14 to 16. The 7 to 10 stays the same. But I just wanted to make sure you understood that there was an errata that came out for the Roadside Design Guide in 2015. And it adjusted this adjusted this table a bit. There was an error that was made. If you do look down in this table, you realize 30-foot, if you go to the left there, you realize the 30-foot spacing is essentially in the higher speed, higher volume kind of situations, which is what you'd expect. So, but remember, again, the limitation here, right, is that there's an assumption of this table, and this 30 feet, or just the table, is that above that clear zone, above that, especially at high-speed situations, 20% of your vehicles are still going to exceed that clear zone. So what you want is as much clear zone as you can get, of course. Now, this is a situation, this picture here is a situation where it's probably about 30, maybe even a bit more away, excuse me. But again, somebody ended up hitting this, and there was a fatality here, and you can see maybe why. This is actually, if you look behind these pillars, you see this is on a curve. We'll talk about high-risk locations with regard to all hazards, and outside of curves is a big one. And so you need to be thinking about also the higher-risk locations and do what you can. So we have our first question here, our first poll question. Oops, sorry, moving on.
Perfect. Thank you so much. Nope, we're going to move right over to our first poll question, which is the definition of a clear zone is what? The farthest a vehicle can travel when it leaves the roadway, a distance that never extends beyond the rights-of-way line, an obstructed, traversable area provided beyond the edge of the through-traveled way for the recovery of errant vehicles, or I don't know, I don't remember. I'll give everyone just a couple seconds to go ahead and fill that out. And again, if you do have any questions for Keith, you can put them over on the left-hand side in the chat pod. Keith will be having 2 other question and answer periods as well. Okay, and Keith, it does look like everyone has gone ahead and answered, and I just broadcast those results for you.
Okay, well, good. People are listening. That's great. Thanks. You're right. That's exactly the correct answer is C there. Thank you.
Okay, and I will move you back over to the presentation. And we did have a request, Keith, to have you speak just a tiny bit louder or closer to the mic, just so that you are aware of that.
Okay, I apologize for that too. I'm getting over a 10-day, if anybody's been traveling at all, you realize I have throat and chest issues going on, cold stuff, flu stuff, and I'm just getting over that, so I apologize. Okay, so within the roadside, there are all kinds of different hazards and obstacles, things that aren't doing what they're supposed to be doing. They're in the clear zone, and they're not breakaway and that kind of thing. And it includes everything from edge drop-off. Trees are a big percentage of fatalities for rural roadway run off the road. Poles, signposts, mailboxes, ditches, steep slopes, drainage features, and there's many, many more. And we'll talk about a few of these and kind of the information that might be of help to you. Some of them we won't talk about. There's information out there in a number of different resources, which, again, if you'd like me to provide to you, just let me know. But you do see, again, that ditches and slopes in here can actually be a hazard just in and of themselves. And so it's important to recognize that even when a slope is clear, the slope itself can be a hazard. Within the Roadside Design Guide, they essentially list kind of 6 approaches to addressing obstacles, hazards, kind of in order of preference. The first one, of course, is you'd like to remove these things if you can. The second would be to redesign it, make it traversable, make it so that people don't get caught up on it, and that kind of thing. Third would be to relocate it, move it out of the clear zone, move it further away, extend that culvert, that whatnot, outside the clear zone. You can reduce the severity. Breakaway signposts are a perfect example of reducing severity, because we have to have some stuff that's within the roadway right away, within the clear zone, but if you make it breakaway, of course, you now have reduced that severity dramatically, and they're designed to be hit and broke, right, in a particular way. And again, Dick will talk more about what's going on with the MASH approach to things. And of course, you can shield it. And again, Dick's going to talk about the barrier side of things. So last one is delineation. So that really, is, hey, the best we can do, the worst we can do, if you will, is at least put an object marker on it, make sure people know that it's there. So starting from that edge line out, again, one of the things we can do and where the recovery begins, of course, is the shoulder, and paving shoulders does have a crash modification factor clearing, crash modification to it, crash reduction to it that we'll talk about, particularly on the outside of curves. Whoops, looks like I maybe missed one of my animations isn't happening here. It's supposed to say on the right that shoulders are really important. So curve, paving shoulders, you don't always have to pave all the shoulder. You sometimes can do it in those critical locations. And one place that's a critical location would be the shoulder side of things on the curves, the curve, like they have done here. Oh, there it is. I don't know how that happened the second time, but it occurred. So within the Highway Safety Manual, the Highway Safety Manual was done in 2010. If you don't have this, again, it's a highly valuable document, relates to what we know, at least what we knew in 2010, about the safety impacts of many geometrics. Now, if you want some more current information, go to the cmfclearinghouse.org, and you can pick up all the stuff that's in the Highway Safety Manual, plus, I'm going to say, thousands of others. We have a number of courses, including low-cost safety improvements that that basically talks just about crash modification factors. And crash modification factors, just very simply, are the impact of safety improvements, the expected impact of safety improvements when they're implemented. And they can go up or down. So what you see on this graph is actually a modification factor for essentially paved shoulder width that relates to average daily traffic. And again, crash modification factor, along with whether it's a wider shoulder than 6 feet or a narrower shoulder. And you can see over on the left, it ranges between 0.98 and 1.1 for 400 ADT and below. And over on the right, for 2,000 and above, it ranges anywhere from, if you have a wider shoulder, you might get a 13% improvement in your, a reduction in your crashes, to as many, if you have 0 feet in your shoulder, a 50% increase in comparison to a 6-foot shoulder. So they've just connected those two lines. Now there is another table in the Highway Safety Manual if you're looking at composition of shoulders, turf, composite, paved. That's actually just set up to impact, show the impacts of when you're changing the type of shoulder you have. Now this, you can't really read it, but up there in that table, you can see that this applies to single vehicle run off the road, multi-vehicle head-on, opposite direction side swipe, and same direction side swipe. So it also has to be applied to the proper types of crashes. So again, lots of information in the CMF Clearinghouse and the Highway Safety Manual. This one's just for shoulder widening. Edge drop-off, not a CMF out there for edge drop-off, but edge drop-off is not a good thing. AAA, again, did this study about 10 years ago that showed this relationship around 2.5 inches. That pretty much matches up with what a lot of maintenance approaches are with regard to when we start making sure we fix those. These happen naturally. They also happen due to traffic and any number of things. You can see this picture here. This was actually a location of a fatality where they were doing some new paving and kind of failed to pull up the shoulder here, and it looks like there was some erosion there. So there may also be a relationship below that, so it's always good to get rid of that as best you can. One of the things that helps out a bit on that would be the safety edge. And the safety edge has been around for quite some time now. It's actually, here in Iowa, something we use. It's in the policies. So all of our contractors have the capability of essentially doing a safety edge, which is this 30-degree shape that provides some stability, again, for vehicles that do happen to leave the roadway. And you pull the shoulder back up like you see here on the bottom, and it helps, again, as that gravel and whatnot and that shoulder moves around a bit. There is at least a 6% reduction in total crashes here, but because it's such an easy thing to do, the benefit cost is very high. So you can see the range of benefit costs here, and you can't kind of argue that. In fact, this next picture shows exactly what I think I'm talking about here. You're basically just shaping stuff that's already there. You're not adding a lot of material. We've done this in both asphalt and concrete here in Iowa. Now the concrete, you're adding material, but here, for the most part, there's not a lot of extra cost. They put a little shoe on their equipment and they shape it. And you can also see that based on the reading on this is you can see that that pavement edge also becomes more stable. You can actually see the sloughing off and whatnot on the right, the cracking. And so you're compacting that. And so it helps out there too. It increases that compaction. And here's a picture again of, you still have to pull this back. Just do exactly what you normally do. People won't even know it's there. But when they need it, it is there. So that's, again, a good thing, especially since, again, that benefit cost is so high. The other thing we can do, of course, as we're moving out is to flatten the slopes and ditches to reduce rollovers, overturns. The overturn, I'm going to go by memory here. Dick, correct me if I'm wrong. I believe about 30% of rural runoff the roadway fatalities have a most harmful event of overturn. So it's a big percentage of our rural roadway departure fatality issues when it comes to circumstances. So this is the before, and this would be the after. So they're fixing this out, and you can see essentially they've increased their clear zone here, and we'll talk a bit about slope and kind of traversable slopes between and non-traversable slopes. This comes out of the Roadside Design Guide. And again, I encourage you to go to read the Roadside Design Guide. It's a great document. They talk about foreslopes and back slopes, and so of course what we're talking about with foreslope is shown in this picture. And back slopes, transverse slopes, which would be your driveways and that kind of thing, and then drainage channels. Now the definitions that they provide for the parallel foreslope are these. A recoverable slope is 1 to 4, 1 vertical, 4 horizontal, or flatter. And basically that allows a vehicle to generally stop or slow and kind of return to the roadway. A non-recoverable slope are those between 1 and 3 and 1 and 4, and it's traversable, so they're making it through it, but they're probably not likely to not stop or get back up there. So we're talking about a clear zone that now they're at the bottom of the slope, and what's at the bottom of that slope matters too. Okay, so they may make it down there. We just don't want them running into anything down there. So when you look at the clear zone and you do start doing those calculations based on the guide, you're going to see that it's all related to these slopes also. And then the critical slope is, again, steeper than 1 to 3, and what they're likely to do there is overturn or roll over on this kind of slope. So these are important definitions to know. There is a crash modification factor in the Highway Safety Manual, and this one's for flattening side slopes. And it's for rural 2-lane roadways, and it's total, all crash types. Whoops, I just lost my presentation, sorry. All right, back. Sorry, I'll take some water here. So this is the slope before and the slope after. You can see it runs 1 to 2 to 1 to 6 on the left and 1 to 4 to 1 to 7 on the right. It's based on some research. Again, if you have the Highway Safety Manual, you can look up what number 15 is there in the title. But you can see the reductions. So these are CMFs, and they're all less than 1, which means there's an expectation of crash reduction. And you can see that it runs anywhere from 0.97 to about 0.85. And that basically means a 3% to a 15% reduction depending on what kind of changes you're making. So if you were trying to predict those type of crash reductions, you could do that with this table. And of course, you always want to consider what's at the bottom of that slope. If they're going to end up down there and there's something bad there, we can get into the discussion that Dick's going to talk about with regard to shielding, because someone ending up upside down in the water is worse than someone hitting a guardrail, if that makes sense. So you want that first warrant of the guardrail, and in some cases it can be what's beyond it, right? In fact, it's always what's beyond it. Different subject. I'll let Dick talk about that. All right, now we get to question on sloping.
Okay, and I'm going to move us over to our second poll break. And the question for everyone is, the Roadside Design Guide says recoverable parallel foreslopes are those with a slope ratio of IV to 4H or flatter. True, false, I don't know, or I don't remember. And again, we are taking questions for Keith. If you do have any questions, please go ahead and put those in the chat pod over on the left-hand side. I'll give everyone just another second or so. Okay. Keith, I have broadcast those results for you.
Okay, so the answer to that question was true. The recoverable force slope is 1 to 4 or flatter, in which they're able to generally stop or slow and then return to the roadway, at least in general. So about 9 out of 10 got that. So thank you very much.
And it does not look like at this time that we have any questions for you, so I am moving you back over to the presentation.
Okay. All right. Well, again, and a lot of this, if you know about roadsides, a lot of this is probably not new to you if you've been into the roadside safety area for some time. Just very quickly, just a few more slides. A lot of these are, again, maybe common sense, maybe not. So again, one of the hazards we've got out there are cross-drainage features. We have these head walls. Sometimes these are draining things that don't even drain things anymore. They've been around a long time. We have parallel, we have cross-drainage. And of course, one of the things, if you remember the list of 6 from the Roadside Design Guide, you get remove and relocate and redesign, and you can make these traversable. I won't get into the details of these designs. Can be found in the Roadside Design Guide, can be found in the Roadside Safety NHI course, but there are certain widths of piping and things like that in which you're required to start putting in crossbars and that kind of thing because of the studies that have been done on these. But you can make these traversable if you redesign them. With regard to trees, again, I wish there was a CMF that said, and there is some data out there that talks about crash reduction, whether it's trees or otherwise, of moving objects further away from the roadway. They're in the CMF clearinghouse and some other documentation. If you want, again, you can contact me and I can provide those. Some of it is relatively old, which is why I didn't include it. But of course, it shows that the further away you have these, the more crash reduction you're going to have. With regard to tree strategies, NCHRP 500, and I'll give you a few other resources. You certainly want to avoid putting them in high-risk locations, remove them if they're there, shield them if they are there, and delineate trees. And there's certain things that are listed as high risk. Yeah, one of them is, of course, things that are closer to the travel way, as I just mentioned, outside of curves. And I always mention, if I'm walking a roadway with someone and they're just looking to do some spot improvements, I'm looking at curves, I'm looking at water features, I'm looking at steep slopes and this kind of thing to determine, I'm looking for particular places first, and then I'm going from there. And of course, non-recoverable slopes, right? Because they're gonna go down this slope, and if it's there, they can hit it. And just like signposts, again, you get above that 4 inches combined or singly, and you're talking about a hazard. And don't forget about those stumps. There is a figure, again, in the Roadside Design Guide that relates slope to height at 4 inches and below. You don't want these to become hazards just in of themselves again, because people have their undercarriage hooked up on it and they flip over. So don't forget these can result in problems too. My figure's not really showing very well here. This photo on the left, at least if it's looking to you like it is to me, is a gray bar. But there are some resources. I mentioned NCHRP 500. There's a 2016 document on noteworthy practices related to roadside trees and utility poles. And there's also a video out there called Highway Safety and Trees, The Delicate Balance. So if you wanted some resources, they do exist with regard to trees and how to approach trees on roadsides. And I know, again, I recall seeing, I think it was a CMF on something in urban areas related to moving them further away from the roadway. And because we're talking rural today, I didn't want to include the urban one in this presentation. Last but not least, I want to talk a bit about mailboxes. Mailboxes can be a very personal kind of thing for people, and you want to be very careful as you're approaching these as hazards. There's a whole chapter in the Roadside Design Guide just about mailboxes, is my recollection. And there's processes that most groups use with regard to notifying people and having discussions with them. I compare mailboxes and trees, put them in the same kind of group. They're very personal to people that live along roadways. Oh, my pictures aren't going to show. Let's try another one. Nope. Oh, there's one. Let's try it one more time. Nope, it just seemed to be kind of random here. Okay. This one, the one that's up in the left, is non-conforming, and this one isn't either. This is a transmission someone's decided to make into a mailbox. And trust me, it's a hazard. And sometimes you got to pick your battles. And I'm trying to see if I can get the third one up. Now, this one is one of the conforming ones. This is a 4x4 post. And there's, again, within the the Roadside Design Guide, you get into different types of conforming designs, 4x4, 4-inch diameter wood, 1.5, I think it is, with regard to light steel or something like that. You have the swing away ones, that kind of thing. So there are designs that do meet both the U.S. Postal Service requirements and are not hazards. It's just a matter of, again, people make them their own, so it's not an easy thing to change. Again, this is, I guess, the last one. I did throw out the sign supports. Dick will talk a bit about this. There's lots of different breakaway designs. The list of eligibility letters is still on that Federal Highway website, but it's archived now because they're focused on MASH. And so those are FHWA 350 and other things. So it's a matter of just recognizing that. But there are some designs out there that have been tested before MASH, I guess is the way to put it. And Dick's your expert on the new testing, which is why he's presenting that today versus me. One more question here before we try to answer others.
Yep, so we are going to ask you guys one more poll question, and that is, what are some of the methods to reduce the potential of a crash when a vehicle leaves the roadway? Shoulder widening, safety edge SM, flattening slopes, all of the above, or I don't remember, I don't know. And again, I do want to apologize to everyone for the animation issues that we are having. Montana State University is experiencing some internet outages today. So luckily the webinar is working, but it does seem to be affecting some of the photos loading. So I do apologize for that. Keith, we do have quite a few questions that came in while you were speaking on this last time. So after we end this poll break, I will ask you some of those. Okay, I have gone ahead and broadcast these results for you.
All right, yeah, it was all of the above. So I just included a few of the ones that we just talked about, maybe, yeah, not all of them, but some of them. And so it was all about the top three. So thank you.
Perfect. The first question that we do have for you is, what is the typical shoulder width and side slope for rural roads? Not the safety recommendation, but the reality. Right.
And it looks like Dick has typed out an answer at the bottom here. And that was exactly what I was going to say, Dick, also. There's a lot of variability in what the agencies use. So what you see in that graph is simply based on research, right? And a group of people getting together and putting all the research together and drawing some lines on a graph. So I hate to put it that way because it's much more complex than that. But and so what Dick is saying here is some have no paved on most roadways. Getting even a 2-foot shoulder, getting what you can get is good, and that kind of thing. So, yeah, you're going to see a lot of variability out there. It's all based on, like you said, the reality of the situation as to what you get, whether roadway was even designed, right? So, different standards in different places, or guidance is a better way of putting it, I guess.
And a second question came in for you as well, Keith. It is, what approach is recommended for CMF without a standard error? Without a standard error, the CMF values have the potential to be highly variable.
Mm-hmm. So this sounds like a question from somebody that's been working in the CMF clearinghouse. And the CMF clearinghouse, like I mentioned, has thousands, if you will, of CMFs. The fact that you're recognizing that is really important, and you'd want to share that. If it's the only one that you've got, like I've always said, we use the best information we have, and we have to recognize its weaknesses. And there are a lot of things in the, there's a highway safety manual, you know, if they're bolded or they're italics, they kind of define that whole thing, and they can put a star ranking to them and everything else. And if something's done to a level that they can't star rank it, it's really basic. In some cases, I'm trying to remember if they even can put a star ranking to something that doesn't have a standard error, and I'm just not recalling right now if they can or not. But what I would say is very much recognize that they can be highly variable, and you try to pick the ones that aren't highly variable. But if you have nothing else, then you just have to make sure everybody knows that. But if you don't have a standard deviation, you can't even give a range, really. You just don't know. So you do the best you can with the best you got. Wish I could be more specific than that, but that's just the reality too, I guess. And remember too, with the new highway safety manual coming out here in 2020, the one in 2010 was mostly focused on geometrics. There's been so much research done in the last 8+ years, because of course they didn't even take into account some of the stuff in 2009, 2000, right before they published. So you're talking 8, 10 years of additional safety work, which I think will make it that much more valuable, and it'll get into maybe some of the operational stuff, some of the very basic stuff that we already do that has safety impact versus just the geometric part.
We did have one more question that came in for you, Keith, and it is, are there ground-mounted breakaway sign supports that can be used in work zones?
Dick, do you have an answer to that?
Yeah.
My reference would be to check the list.
Yeah. Let's, if we could hold that, I think I will be talking a little bit about the sign supports for work zones in a bit.
Okay. Yep. All right.
Perfect.
Thank you.
Then, Dick, we'll hand it over to you.
Okay. Well, great. Again, my name is Dick Albin. I'm with Federal Highways Resource Center, and I'm going to be covering the second half of this webinar, where we're going to look at identifying the criteria for determining the crashworthiness of roadside hardware. We're going to talk about the implementation plan for MASH, and we're also going to be talking about some hardware that's been tested to MASH. And as Keith showed you earlier, when we're talking about roadway departures, we have our 3 main objectives. And we talked about, excuse me, I don't know what happened there. Okay, we talked in our previous webinars about trying to keep vehicles on the road. That's our main objective, is if we can keep all the vehicles on the road, we don't have a roadway departure problem. But we know that we're not going to be able to always do that, even if we implement rumble strips and curve signing and friction treatments and things like that. So then we look at what can we do to reduce the potential for a crash if somebody does leave the roadway. And so Keith earlier covered the clear zone and providing shoulders, and also the safety edge so we don't have an abrupt drop-off. But now we're to the point where we know that people are going to still be running off the road, and we can't always provide a perfectly recoverable side slope or a risk, object-free clear zone. So what we're trying to do now is minimize the severity of a crash. And generally what we're talking about is using some type of hardware, like a barrier or a sign support if it's a sign that's out there, that we can make crash-worthy. And when we look at the data, and this is the data for rural roadway departures, and so that's the third of all fatalities. About 12,000 people a year get killed as a result of a roadway departure on a rural roadway. And so here you see the breakdown. Keith mentioned before the head-ons are about 28%, rollovers are about 30%, trees are about 19%. Those are our big 3 crash types. So if we want to do something to improve safety, we have to do something with those 3 crash types. But if you look at the next couple, the poles and signs and barriers, those are things that we put out on the roadside to try to reduce the risk by giving information with signing, or it might be a luminaire pole for lighting. It could be a signal pole. It also could be a utility pole, which really isn't there for anything to do with the roadway, but we have to accommodate. But then you also have barriers. And so all the data on here is looking at most harmful event. So for, on average, about a little over 300 people a year are killed when they ran into a barrier that we put out there to make the road safer. And so what we want to try to do, if we're looking at something like a barrier, is to make sure that it is crash-worthy. And so we're going to, there are so many different ways I could go with this part of the webinar, but we decided to focus it in on just going over what is the criteria for crash testing and how is it being implemented, as opposed to getting into all of the placement type issues and things like that. But again, what we're looking at is putting out hardware that is considered crash-worthy, whether it be barriers, the terminals or crash cushions that go on the barriers, breakaway sign supports, or work zone devices that we put out along the roadside that we know people are going to run into. We know putting it out there that it's going to get hit. So the way we assess whether it's crash-worthy or not is we run a crash test. We run a vehicle into it and to see how it will work. And the current criteria for crash testing is found in the AASHTO Manual for Assessing Safety Hardware. And the acronym for that is MASH. So you'll hear MASH being talked about quite a bit. And MASH replaced a document called NCHRP Report 350. It was a document that was developed through research. It was published as a research document. And then Federal Highways formally adopted that Report 350 back in the 90s. But going forward, AASHTO decided that they wanted to be more in control of the crash test criteria, so they decided to make it an AASHTO document, and that's where we have MASH. Now, what MASH does, and also NCHRP 350 before MASH, is it specifies what tests need to be run for different types of hardware that we might put out on the road. It's based on what we call the worst practical conditions. And I'm going to come back to that in just a second. For barriers, there's actually 6 different test levels that could be run. And we'll get into what those test levels are in a minute. But there's also matrices for how to test the ends of the barriers, the terminals, the crash cushions, sign supports, and those work zone devices. Now, let's talk about worst practical conditions. When we think about the severity of a crash test, there's really 3 main variables involved. There's the mass of the vehicle, there's the speed of the vehicle, and then there's the angle of impact. And so all 3 of those are specified in MASH to tell researchers or state agencies or manufacturers what conditions they need to use to develop those tests. Now, we know going in that we can't test every single vehicle make that's out there. It's just not practical to consider doing that. We also know that we can't test every angle and speed combination that might exist or might happen on the roadside. So we have to select a couple conditions that kind of encompass the majority of crashes that might happen. We also need to have hardware that will pass the test. So we can't necessarily set conditions that are so high that nothing passes. That wouldn't really help anybody. Now, when we talk about the vehicles that are now used under MASH, we use typically most hardware that we use on our roadsides are tested with these 2 vehicles. A small car, which is about a 2,400-pound vehicle. A typical vehicle that meets the spec is a Kia Rio, very popular vehicles out on the road right now. And then on the upper end of the passenger vehicle fleet, we have a pickup truck. And it's a 5,000-pound quad cab pickup truck. And between those vehicles, we're trying to encompass the majority of vehicles. But there will be some vehicles that exceed the weight of the pickup truck, You might have a Hummer or an Excursion or a Suburban or something like that that might be heavier, or you might have a vehicle that's on the lower end that is less than the Kia Rio. But the Kia Rio represents, at the time, about the 2 percentile. So there were only about 2% of vehicles that were being sold that weighed less than that. And the pickup truck were represented about the 90th percentile. So there were only about 10% that were being made that weighed more than that. So the feeling was that that encompasses the majority of crashes that happen out on our highways. In some cases, though, we might add another vehicle. We might add in a larger truck, like a furniture moving truck at test level 4. This weighs 22,000 pounds. At test level 5, we add in an 80,000 pound tractor trailer. And then at test level 6, we add in an 80,000 pound fluid tanker. And these would be used where you expect those higher center of gravity vehicles, those higher weight vehicles, and there's something that you want to make sure that you can contain those vehicles. Now, when we talk about test levels 1 through 3 are defined by speed. So test level 3 is our basic design level, test level, and that has a speed of 62 miles per hour. That you see some odd numbers on these, and that's because it was developed in metric first. So it was actually 100 kilometers per hour, and then that converts to 62 miles per hour. And then you have test level 2 at 44 and test level 1 at 31 miles per hour. I know there are many roads out there that have 70 mile an hour posted speeds or even higher, but the test level 3 is the highest speed that we have, and that's generally considered acceptable for high-speed facilities. The document that we show there, the NCHRP report 665, was actually developed as MASH was being developed, and what it found was that the 62 miles per hour represented about the 85th percentile crash. When a vehicle runs off the road and crashes into something, that was about the 85th percentile. It also looked at the angle of impact. We basically test these at a 25 degree impact angle, and that was about the 85th percentile as well. So this test level 3, even though the speed may not be as high as all the other some highways that you might put them on, it is still considered a fairly significant test, a very severe test. At test levels 4, 5, and 6, again, we add those larger vehicles, but we don't test those at the higher speed. Test level 4 went to 56 miles an hour. Test levels 5 and 6 are at 50 miles an hour. Let's see. And again, the test level 3 is considered our basic test level. Now, there are some limitations on quick testing. Generally, when we test something, it's under semi-idealized conditions. They're usually done out on a flat runway somewhere. A lot of the testing is done either at Texas A&M University or a Midwest research at the University of Nebraska. There are other test labs, manufacturers and others use, but those are the two main ones that we see a lot of testing out of. So they have a big, wide area. Generally, the vehicle is going whatever speed they have and the angle, but they're also doing what we call they're tracking, which means that the back tires are following the front tires. There's a study going on right now, NCHRP 1722, that looked at the conditions when vehicles ran off the road and hit something, and they found that a lot of vehicles aren't tracking. Some of them are sliding sideways. You can see 37% are in a lateral skid counterclockwise, 25% are going clockwise, and 9% are in a lateral skid. But that is a very tough thing to crash test. But just being aware that we're not going to be able to accommodate every type of crash that might happen on the road with our crash test criteria. Also, we use the vehicles that we showed over on the left-hand side, the small car and the pickup truck. But we know that sometimes people jack up their pickup trucks or they have different vehicles that maybe don't meet those specs. But we think that this crash test criteria accommodates the majority of vehicles that are out there. Site conditions may vary. And again, this is something we really couldn't get into in the length of this webinar. But having your hardware, whether it be guardrail or a sign support, when you start putting it on slopes, that can change things. The vehicle may not hit it the way it's supposed to. Soil conditions may affect things. Having a curb in front of it, that may lift the vehicle up before impact. And then devices may not be installed the way that they were designed. When you get out and install it, and then you have some maintenance done on it, sometimes pieces don't go back the way they were supposed to. And so it is important to try to make sure that you get things installed the way they were tested and that they are maintained that way as well. Okay, looks like we have some time for some questions. I see that there are some in the chat box. I'll try to come over and see what we got here.
You do? Okay. As Dick is taking a look at those, I will read out these next poll questions for you guys. What is the name of the current crash test criteria? Smash, mash, bash, crash, don't know or don't remember? And then what is the impact speed for test level 3? 55 miles per hour, 70 miles per hour, 62 miles per hour, 73 miles per hour, or don't know, don't remember? And again, we'll give everyone just a few seconds to go ahead and fill those out. Okay, at this time, it does look like everyone has filled those out, so I'm going to broadcast these results for you, Dick.
Okay, it looks like everybody got the MASH question. I actually advocated when MASH was being developed, I like SMASH better myself, standard methods for assessing safety hardware, but the vote was for MASH, so I have to live with that one. And again, the top speed for test level 3 is at 62 miles per hour. We don't have a 70 mile an hour test speed. So let's see, I see a question regarding motorcycles, and are they considered in different test levels? And right now, the U.S. does not crash test for motorcycles. It is a very tough thing to try to do. There isn't a lot of protection around a motorcyclist. Europeans have been doing some testing. They've been looking at testing guardrail where the motorcycle is either on the ground and slides in and maybe gets underneath the guardrail and hits the posts. And that is probably the most severe thing for the motorcyclist, is hitting anything that's coming up out of the ground vertically. They also have done some testing where the motorcyclist is upright and they basically slide along the top of the posts, kind of raking across the posts as they go. And there are some, the manufacturer did develop something where it's kind of a curtain that goes down below the guardrail to try to keep the motorcyclist from getting down below and into the posts. We haven't seen how effective that is yet, but it has been used in a couple places in the United States. I see Michael had a question. So head-on collision consists primarily of drivers inadvertently crossing the center line and crashing into an oncoming vehicle. Yes, that's correct. When we look at our head-on crashes as part of roadway departure, just a percentage, a small percent, I can't remember the number right offhand, but it's like 10 to 15% are where vehicles crossed over a median. Most of them are crossing over a center line and hitting another vehicle when we look at the head-on crash type. Okay. See, somebody else is typing. I'll try to catch that one in a few minutes. Okay. So we've talked about what is MASH and what is the process for determining crashworthiness of hardware. Now we're going to talk a little bit about how to implement, or how AASHTO and Federal Highways agreed on an implementation plan for MASH. And this is where you can see some things that are changing in the next couple of years. You've probably already seen some changes if you're looking at this. So the first thing is when MASH was first published back in 2009, there was an agreement between Federal Highways and AASHTO about how it would be implemented. And in general, the feeling was that while MASH had to be created because vehicles had to be adjusted. The vehicles that we were using before in NCHRP 350 were no longer being made. So they had to adjust the vehicles and come up with new crash test criteria. But the feeling was that NCHRP 350 was really pretty good. So at the time, AASHTO and Federal Highways agreed that you could continue to use NCHRP 350 hardware, although if you're going to do new testing, it should be done to MASH. Now, in the last couple of years, there were a lot of things that were looked at involving guardrails and things like that, and there was a decision made by AASHTO and Federal Highways to go ahead and push the implementation of MASH. And so AASHTO adopted a plan, and I'm going to go over some of the excerpts from that plan. One of them had to do with existing hardware. And the question is if we go to MASH hardware for new installations, what do we do with all that stuff that's out on our roads? You might have stuff that was installed in the 1950s or 60s that wasn't crash tested originally. What do we do with all that? And so there was some guidance given. First off, that agencies are urged to establish a process to replace existing hardware that has not been tested to 350 or MASH or later criteria. And then also agencies are encouraged to upgrade existing hardware to MASH when it becomes damaged beyond repair or when an individual agency's policies require an upgrade to safety hardware. And basically all that's saying is that we knew that it was going to cost money to go out and upgrade existing hardware, and that you have to weigh off priorities. So it's basically the implementation plan just encourages you to think about how you're going to do it and have a process, and think about maybe how you're going to upgrade hardware that's been out there since the 1950s. Maybe it's as you go through with paving projects. Maybe it's as it gets hit, things like that. So, this was meant to give a lot of flexibility to agencies to determine what is the best fit for them on how to update their hardware. And ultimately, they're going to have to be able to justify that if there's ever questions that are raised. Now, for new installations, though, when you're putting out brand new hardware, the AASHTO implementation plan says that you should put out hardware that meets MASH 2016 when you're putting in new permanent hardware or when you're fully replacing hardware that's out there. The implementation plan was geared toward the National Highway System, or NHS, and that's because that's where Federal Highways has some influence, if you will. But a lot of states basically use this plan for all of their roads. Again, that's something that each agency will have to be able to justify whether they are or aren't on individually. But in general, it's a lot easier if you're just applying the same criteria on all your roads. But then it gave some dates. So the different hardware types, they were staggered out depending on things that were fairly well tested at the time, and giving more time to some of the proprietary items that were out there that we knew were going to take a little bit more time to get tested and get on qualified products listings and things like that. And so I'm just going to go over some of these dates. And these are all of this implementation plan is posted on the AASHTO website. You can see the web link down below here. So the first date was December 31st, 2017. So that is now passed. It was end of 2017. And that was for W-beam barrier and cast-in-place concrete barrier. The next date was for June of 2018. So that date is also now passed. And that was for the terminals to W-beam guardrail. The next date, which is coming up, the end of this month, in a couple days now, is cable barrier terminals, and crash cushions. And then the last date was the all other category. So bridge rails, transitions, other longitudinal barriers, including portable barriers, all other terminals, sign supports, and breakaway hardware. Now, this plan had to be adjusted a couple times. It was revisited. And what happened was, as we got close to those dates, so getting close to the December 31st date, there was a realization that we didn't have all of the bases covered. We didn't have all of the hardware applications tested that agencies might need to have. So what AASHTO said was they put out this clarification that said that sunset date of December 31st is for the standard installations. but special applications like using it with reduced post spacing or on a flare or with curbs or at bridge ends in restricted areas, those were being pushed out to the end of 2019. So that has been adjusted. And again, that adjustment is shown out on the AASHTO website. Now, one of the systems that a lot of agencies have now converted to is called the Midwest Guardrail System. This is a system that was developed before MASH. It was actually developed under NCHRP 350 by a group of states in the Midwest, kind of centered around the University of Nebraska, and they started looking in the early 2000s of how to improve the performance of W-beam guardrail, considering that we have larger vehicles out there. And so they developed this system called the Midwest Guardrail System. And let me see how my bullets go here. Okay, Midwest Guardrail System uses the same W-beam rail system that we've been using for, since the 1950s. The same shape of the W-beam and things like that. It uses the same 6-foot-long posts, and they can be steel or they can be wood, but 6-foot-long posts are on the standard system. But what they did was they raised the height of the guardrail up from a nominal height that was at 27 inches, maybe it's 28 inches because of metric conversion, but they raised it up to 31 inches. And what that did was it better accommodated the larger vehicles, those bigger pickup trucks that we were seeing on the road. But they also then added in a deeper blockout. And you can see in this photo here, you got a wood post system, and the blockout is what's separating the guardrail from the post. And so typically that guardrail blockout was an 8-inch blockout, and they went to a 12-inch blockout to try to reduce the potential for a small car to get underneath and catch on the post. The other thing that was done was that they moved the splice between the rail, the two pieces of guardrail. And I'm trying to see if I have a pointer here, but right in between the posts, you can see in this photo that that's where you can see the bolts, right where there's no post at. That typically in the past was always at a post. But what they found was that when you have the splice at a post and the bolt is going through the hole at that point, when it gets hit, that bolt is being ripped through the rail and it starts tearing. And what they found was if that tearing happens at a splice, it makes the guardrail weaker. And so by moving the splices away from the posts, they basically improved the strength of the system. So that's the main differences with the Midwest Guardrail System versus the previous guardrail, W-beam guardrail system that we've been using since the 1950s. Pretty much all the same pieces and parts that are out there. Now I think I have a video here. Let's see. Oh, I'm sorry, maybe I got another slide here. So the Midwest Guardrail System has been tested with wood and steel posts. It's been tested with the 12-inch block originally, but it was also then tested with an 8-inch block, and that did pass the crash testing with the small car. And there are a couple designs that have been tested with no blockout at all. So if you're in a really tight area where you don't have any room for shoulders, even shoulders, that you might want to might be able to leave off the blockout. But I can tell you that it's always going to be better from if you ever had your choice of what to run into, you'd rather run into one with a blockout. There's also been designs that have been tested with long spans where you've left off posts. What we're showing here on the screen is leaving off 3 posts. So if you need to go over a fairly large culvert or some obstruction in the ground, you can leave those up to 3 posts off. You do see that there is a weakened post on each side of the gap that you have there. The big difference with the Midwest Guardrail System with the long span is that previously you had to nest the rail, so you have one piece of rail inside the other. This is just a single piece of rail going across. Midwest Guardrail System has also now been tested in front of a 2-to-1 slope, and with the posts on the 2-to-1 slope, as you see here, and that passed with a 8-foot-long post. It's also been tested with curbs in front of it. So there is a lot that's already been tested with the Midwest Guardrail System, and most states have kind of converted over to that at this point. Okay, so
Dana's going to go ahead and move us over to the video now.
Okay.
And again,
so,
this video will not have sound. It will just have motion for you.
and this video is just going to show the crash testing of the Midwest guardrail under MASH. It's just one test that I'm showing you on this one. If it decides to show. Yes. Okay, it looks like it might be doing something. Okay, so you can see this is a MASH pickup truck. When you see a quad cab truck, you know that's MASH. It did contain the vehicle. That's the number one thing the barrier needs to do is make sure it holds the vehicle, keeps it from getting where you don't want it to be. It redirected the vehicle. There was deflection of the rail, and there was no tearing of the rail, and the vehicle was relatively stable. When you look at the older system that was at 27 to 28 inches, you had a lot more lift of the vehicle, and so there was a little bit more instability there. So we can go ahead and go back. Now, I'm just looking over the questions. Mike had a question. What are the approved device for guardrail terminals for facilities parallel to the edge of the pavement? I believe the device used recently was determined not to work. Okay, I'm going to get to terminals in just a little bit, and hopefully I can answer that question then. But we do have a poll question up for you. Which of the following is included in the ASH implementation plan for MASH for existing hardware? Does all hardware not meeting MASH need to be replaced as part of resurfacing projects? Does all non-MASH hardware, should it all be replaced as soon as possible? Our agencies are urged to establish a process for updating hardware not tested to 350 or MASH. I don't know, I don't remember, or no vote. I'll give you a few minutes there. Okay, Jamie, I think we probably have a majority of voting in. The correct answer, 81% of you got, is agencies are urged to establish a process for upgrading hardware not tested 350 or MASH. There is no language in there that says you need to go out as soon as possible and replace all that hardware, or that you have to do as part of resurfacing projects. ASHA wanted to make sure the agencies had the ability to make those decisions and be able to justify those decisions individually. Good. Now, so W-beam guardrail was in the first category, the first sunset date. I'm going to go over some of the other hardware as well in this next session. So we also have concrete barriers, and concrete barriers can come in different shapes. There's the New Jersey shape and the F shape. There's a single slope barrier. There's vertical walls. And all of these have had some testing to MASH at this point. Now, as far as when we look at the height of barriers, the different test levels, the different test levels are the main distinction is the height of the barrier. So to be able to pass the test level 3, which is just with the pickup truck and the small car, a 32-inch high barrier, the New Jersey shape was tested on that, and that did pass. When we go up to the single unit truck, we found that that in the past, a 32-inch barrier did pass with the test level 4 single unit truck, but we found that did not pass under MASH. So what we found was that we need to go up to 36 inches with that, and that was tested on a single slope barrier. And then when you're trying to develop a barrier for a bigger tractor trailer, generally you need to go up to about 42 inches to be able to get up to that. Now these also have to be designed structurally to be rigid, different types of ways of tying into a bridge deck or making them rigid, but that's the general height criteria. And I think I might have missed a video. Did you guys, did we have another video here to play?
We do. If you give Dana a second, she'll move us over to it.
Okay.
Yeah, I'm having a slight problem again. I think it's with our server. This one is
It's probably a longer video, so.
set up to play, and now it's not loading. So if
Okay.
I'll keep trying, and if we want to come back to it in a few slides, Dick, before the next question, how about that?
Okay, and I'll just say that what I was going to show you on the video was the testing with the New Jersey-shaped barrier. This was done as part of the development of MASH. They tested it with the small car, and it did pass. It was also tested with a pickup truck, and it passed. But when they tested it with the larger test level 4 vehicle at the 32-inch height, the vehicle went over the top. So we knew going in that test level 4 we were going to have to go with a taller barrier. And it just depends on when you decide to use a test level 4 type barrier. Okay, so that's our first sunset date was the beam guardrail and concrete barrier. So we've talked about those. The next sunset date had to do with the terminals. And it basically said that the guardrail terminals should meet MASH by June 30th of 2018, which is now passed. But as we got closer to that sunset date, we realized that while we had tangent terminals that had been tested, we really didn't have other varieties like a flared terminal, or if you had a double-sided guardrail, we didn't have that covered. So basically, AASHTO decided that sunset date only was for tangent terminals. And this kind of gets a little bit to what I think Mike was asking in his poll question here, or in his chat pod question. Other applications like double-sided or flared terminals, they were extended out to December 31st, 2019. Now, there are some terminals that have been tested to MASH. There's this one that you see here called the soft stop, which is a head that goes over a piece of guardrail, and it flattens it out vertically as it goes over it when a vehicle hits it. So that's one that's been tested to MASH and is available. There's the MASH sequential kinking terminal that you see here, very similar to its predecessor, the sequential kinking terminal. The main difference with this one is the head on it has a plate over the guardrail, so you don't necessarily see the guardrail where it's going into the head. That's where you can see the etching on the face of the head there. And then there's one called the max tension, which is uses some cables that are anchored out in front to go through a head, and then the rail slides along those cables as it gets pushed back. So these are the tangent terminals that are currently available that do meet MASH. And a lot of states have already have adopted those. Many states adopted these earlier. They adopted them like a year before because they were available. Okay, it went backwards on me. Now, there is one flared terminal that was tested, the slotted rail terminal. It was tested. It received an eligibility letter from Federal Highways. This was done back in, I think, 2011 or 12. However, right now, the manufacturer isn't producing these designs. The flared terminal was pushed out to the end of next year. Maybe we'll see some movement in that. But right now, the manufacturer is still producing the NCHRP 350 designs, but is not producing this one just yet. So if you like flared terminals, we don't quite have a MASH answer for you at this point. I also understand another one called the MASH Fleet, which is the flared energy-absorbing terminal. It was a design that was available under NCHRP 350. I understand testing has been done on it, but we have not seen it ready for manufacture yet on that one yet either. So those, we may see some action on that in the next year. Another terminal, a generic terminal that's out there that recently had some testing done on it, is the buried-in backslope. And the buried-in backslope is different from a turn-down end. You can see the guardrail here maintains its height as it goes into a backslope. So to be able to do this, you need to have a backslope. This one was tested by the folks at Texas Transportation Institute under MASH, and so that is a design that might be applicable if you have a situation where you have backslopes. It was tested going over a foreslope of 4 to 1. And when you do that, you end up with more post exposed as you're keeping that guardrail up high, and that's why you use a rub rail underneath it to try to keep the vehicle from getting in and catching on the posts. Now, the next implementation date that's coming up is for cable barriers and crash cushions, and that is for December 31st, 2018, so just coming up in a couple of weeks. And this is another one where in the summer of this year, there was realization that we didn't have any cable barriers that had been tested to MASH 2016. And there was a difference between the previous version of MASH, 2009 version of MASH, and 2016, and it was primarily to do with cable barrier testing. And I'll show you that in a second. So with the cable barriers, the deadline on that was pushed out to 2019 as well. For the crash cushions, that date was kept at the end of this year. So if you're putting in a crash cushion after the end of this year, it should be a MASH compliant. With cable barriers, we have another year. And there are different cable barriers that were out there that had been tested to MASH 2009, the Bryphon, the CAS system, the Safe Fence. But when it came to testing to the 2016 version of MASH, it got a little bit more complicated. Now, the complication gets into when we start putting them on slopes. And when you put them on a slope, vehicles hit them at different heights, and that's where a lot of manufacturers were coming out with different designs that had more cables, and they were spaced out a little bit more to try to contain the vehicle. And some of these were tested under NCHRP 350 and earlier versions of MASH. But with the 2016 version, we added a lot more criteria for how to test. Under NCHRP 350 and 2009 version of MASH, all we had in it was the test that's shown on the upper left-hand side of the screen, where it's on a flat area. Under 2016, the criteria is put in place for testing on slopes. And no barrier yet that I've seen has met all of the crash tests for this. So that is something that we'll see. Maybe we'll get to the end of next year and we'll find that we don't have any barriers that meet MASH, and we'll have to decide whether we need to change our criteria again. But the crash cushions part of the next implementation date was retained. There's several crash cushions that meet MASH. There's the Quad Guard, the SCI, the Smart Cushion Innovations has been tested now to MASH. We have traffic sand barrels, and I believe that there is also now the TOW system and maybe another sand barrel that's been tested now to MASH. And I just want to, let me go back over to the question that was asked. What is the approved device for guardrail terminals for facilities parallel to the edge of the pavement? Okay, so yes, there were some devices that were available before MASH. There was the ET Plus, there was the X Lite. Those I believe are not being tested to MASH, but we now have this new generation with the soft stop and the max tension and the MASH SKT. So I hope that answers your question, Mike. Now the next thing I'm going to talk about a little bit is bridge rail. So we're getting into that next implementation date, which is the end of next year. And when we look at bridge rails, there's different types. There's concrete, which is basically the same type of test that we did with concrete barrier. So we were really testing the shape and the height, and how you tie it into a bridge deck is a structural calculation that can be done. But there's also a lot of different bridge rails. There's steel bridge rails. There's combination where you have concrete and steel together. And so there's a lot of different variations out there of bridge rails. One project that was done by the folks at Texas Transportation Institute as part of an NCHRP project, they went through and they tried to evaluate the equivalency of existing 350 type bridge rails and whether or not that they would likely meet MASH. They assessed 22 different bridge rails for stability, the geometrics of the rail, the strength of the rail, and they found 12 of them that they thought would perform satisfactorily. Now that is something that as an agency, a state agency, a local agency, you may be able to use that to make determinations of what you might use on your system. But there are also plans to do some full-scale testing under the NCHRP project shown below that NCHRP 2235. They're going to do some of the full-scale testing of some of these. But there are some that have already been tested, like I showed you before, the concrete barriers that were tested that are essentially bridge rails. There's also the transitions to the bridge rails. Whenever you have a beam guardrail or a cable barrier that's coming up and you come to a bridge rail, you have to do something to stiffen up the rail as you get to the end of the bridge rail. So there are some test level 2 designs, test level 2 design that's out there. There's a test level 3 design that you can see in the picture here that has Thri-beam that's coming up to the bridge rail. There's different posts that are used. They're bigger posts usually. You can see the tighter post spacing in part of it. And then there was a design that was tested with a curb as well, so that you can have a curb if you needed it for drainage purposes within the transition section. There's also portable concrete barriers that are pretty heavily used for work zone devices. Some states also use those for permanent barriers as an alternative to beam guardrail. Excuse me a second. And this one that I've shown you, several of them have been tested to MASH. The one that I'm showing you on the screen here is what I call the Oregon precast concrete barrier. It was tested freestanding, where it was allowed to deflect. It was also tested with anchorages that stiffened it up and gave it very little deflection. It was tested not only on an asphalt roadway, but also on a rigid concrete deck as well with the anchorage. There are some sign supports that have been tested. The wide flanged sign support that you see here was tested under MASH. With a single support. There are some multiple wood supports that were tested. You can see the drilled holes that were drilled through, having 3 posts that were tested here. A lot of this testing was done by Texas DOT. They paid for a lot of the testing themselves. So a lot of times you won't see an eligibility letter for those, but I'll show you where to get more information on those in just a second. They also tested a steel support with a slip base, having multiple supports. And again, there's a lot of things that go along with placement of these, trying to have those posts that are 7 foot apart so the vehicle's not going to hit 2 of them at the same time. Now, this one that I showed you here with the wood posts, they did actually hit 2 posts at the same time, so that is a tested system. But in general, if you've tested it with hitting 1 post at a time, those posts should be at least 7 feet apart. Also, when you have a large support like this, you're expecting the vehicle is going to go underneath it. So you want to make sure that sign is at least 7 feet high off the ground. So that is something to be watchful of. But there are a lot of other signs, and there is another project, an NCHRP project, that's looking at testing of signs. Now, the question that we had earlier regarding signs was, do we have a work zone 1 that's in the ground? And I believe when Texas tested this wood sign, they were calling that a temporary design. But I think a lot of people might use the wide flanged channel posts in that type of a situation, or they will use stands like I'm going to show you in a few minutes. Now, when we get to the work zone devices, and again, the implementation date for work zone devices is next year. But with that, some things that are in the implementation plan says that those are that after 2019, December of 2019, devices that were manufactured after that date need to be tested to MASH. But they also recognize that if you purchase something in November of 2019, that you might want to use it throughout its service life. And so they basically worked that into the implementation plan that such devices manufactured on or before the date that were successfully tested to NCHRP 350 or the 2009 version of MASH may continue to be used throughout their normal service lives. Now, from an agency standpoint, what that means is you may have to determine what a normal service life is or when to retire those. That is something that you might need to develop individually. but AASHTO did not give you a definition of what a normal service life is. But the work zone devices includes temporary sign supports. These are usually on some type of base or stand, so they can be moved around. They're not necessarily ground-mounted signs. They could include barricades that you see here, and there are several of these that have been tested. Or they could be different types of barriers, and this is the mobile barrier, where it's basically a bed of on a semi that kind of creates a temporary workspace behind the barrier. So all of those devices, there are some of them that have been tested in MASH already, but if they were in use, manufactured before 2019, they can be used throughout their service life. And this is a resource for you. As part of a pool fund program, there's about 25 states and one Canadian province that put money into a pot every year that pay for testing that's done at the Texas Transportation Institute. And one of the projects that they have is a site. They maintain a site that has all of the different hardware that's been tested to MASH that they're aware of. Not necessarily just the stuff that they've done, but they also have some of the stuff that was tested at the Midwest Pooled Fund site at the University of Nebraska. They also have some proprietary stuff that they know about that is posted out here. So you can go out to this site and you can see the link up at the top, and you can query for the device type. Maybe it's guardrail. You want to know all the guardrail that's been tested, and it will give you information. And when you click on those, in some cases you can get videos, you can get test reports, things like that. So it's something that you might want to be aware of, maybe to go out, take a look at, and just maybe check back on every once in a while. And I guess we're ready for any other questions. I don't think that there were any new ones in the poll in the chat box, but if you do have any more questions, please let me know.
Dick, I have the other video up. Would you like to introduce it again, and I can run it quickly for you all?
Sure, why don't we go ahead and do that. And again, this was on concrete barrier, and it basically is just going to show the testing that was done to MASH. It is a longer video than the first one that I showed you, so it might take a little bit of buffering here.
And again, while that's happening, if anyone has any questions after this, please put them in the chat pod. This will be the last question and answer period.
Okay, so I'm sorry, it looks like we're a little bit over on our time. Hopefully that's okay with everybody. So this is the small car test, and this was a significant test because previously under 350, the small car was tested at a 20-degree angle. And at the time when NCHRP 350 was developed back in the early 90s, they didn't think that small car would pass the test at a 25-degree angle. So this was run at a 25-degree angle to show that the small car did pass. You do see a lot of lift. The vehicle went up in the air quite a bit, but it came down on all four tires, and that was a successful test. Now here's the pickup truck test done with that same 32-inch New Jersey-shaped barrier. And again, there are different shapes. You got the F shape, you got the single slope and vertical. Most people thought that the New Jersey shape was the most critical shape. So by testing that one, the feeling was that all other barriers should work out as well. But now this is the test level 4 test, and you can see in that test the vehicle went over the top. So that's a failing test. The barrier needs to keep the vehicle from going over the top. So that's how we knew that a 32-inch would not pass at test level 4. And subsequently, TTI tested a 36-inch high barrier, and they did some other analysis, and they think that the minimum height for test level 4 is 36 inches. Okay. So again, if you have any questions in the chat pod, I think we might have a couple of poll questions coming up here.
So this is our last poll question. It is, by the end of 2018, which of the following should meet MASH according to the AASHTO implementation plan? All W-beam guardrail elements, cable barrier on median slopes, flared guardrail terminals, standard installation of the Midwest guardrail system, work zone hardware, portable concrete barrier, tangent guardrail terminals, crash cushions, don't know, don't remember. We'll just give everyone a few seconds.
And I'm not sure if it's letting them select all that they want to or if it's just letting them select one here. It looks like I see votes coming off on some of them, so it may only be letting you select one of them. So I guess if you select one, one we'll take that for now.
I believe it's letting them select most or more than one, because it does look like
Oh, is it?
the percentages add up.
Numbers
to
are
more than
up
one.
higher? Okay.
Yeah.
Okay.
All right, one more second, then I'm going to close this out so we can wrap up the webinar.
Okay. All right, so the correct answers on this one, the first one, a lot of you selected all W-beam guardrail elements, but if you recall that there was that clarification that said that that was the standard run and other things like the leaving posts out or on flares and things like that, that was pushed out. So that's what I was trying to get to with that part of it. So actually that would be one that I would say was not a correct answer. Sorry to the 66% of you there if that was confusing. The cable barrier on median slopes, again, that was pushed out to 2019. So not the end of this year, it's the end of 2019 now. The flared guardrail terminals, that also was pushed out to the end of 2019. Now, the standard installation of the Midwest guardrail system, that one was one that was supposed to meet MASH by the end of 2017, last December. Work zone hardware is next year. Portable concrete barrier, again, is next year. Tangent guardrail terminals, the all guardrail terminals got pushed out to the end of, the flared ones got pushed out to 2019, but for the tangent terminals, that was the June of 2018. So that's the correct answer there. And then the crash cushions, that's one that's coming up in a couple weeks. So by the end of 2018, your crash cushions, your tangent terminals, and your standard installation of guardrail should be up to MASH, and everything else will be coming in 2019. Okay, I see a couple of questions. Keith asked, where would you use a three-post spacing? I think you're meaning where you leave 3 posts out, up to 3 posts out. That would be where you have like a low-fill culvert where you don't have the ability to put posts in because there's a culvert there that's in your way. And it was tested with actually leaving 3 posts out so you could actually span 25 feet. So there is a design that's been tested to MASH for that application. There was a question wondering what is the optimal height for semi-trailer truck? For optimal height, I think if you're asking what the optimal height for a barrier for semi, that would be test level 4 conditions, which would be the 42 inches. So if you're trying to develop one for a semi, an 80,000-pound tractor trailer, then you need to be up around the 42 inches. So optimal height of guardrail. If you're, a lot of times with the semi, we're talking about a beam guardrail, a concrete barrier type system. There is one system out there that was a beam guardrail that was tested with the semi, and it is a very tall one. It actually has a tri-beam section with a piece of W-beam on top of it, so it's pretty high up. Okay, and let's see. So I think I see Tori added in correction on the NCHRP 500 report. Other than that, I don't see any other questions.
Okay, perfect. Thank you very much to both Keith and Dick. We do appreciate you guys taking the time today to do the presentations and to answer all of the questions, and especially to show some of the videos as well, which helped to describe exactly what you guys were talking about. So in this webinar today, we hope that you guys have learned to define clear zone, its basis and limitations, to describe critical, traversable, and recoverable slopes, to list some methods to reduce the potential to crash when a vehicle leaves the roadway, to identify the criteria for determining the crashworthiness of roadside hardware, to describe the implementation plan for MASH, and to identify hardware that has been tested to MASH. We do want to remind you that we have an upcoming webinar on January 31st at 11 a.m. Mountain Time. It will be on the framework for bikeway designation on rural roads. We will be announcing some additional upcoming webinars, and I apologize that says 2018, but clearly that January one is in 2019. I also do want to remind you all that this was part 3 of a 3-part series. You can find the other 2 on the ruralsafetycenter.org under our archived Safety Center trainings. There was also a previous webinar on the Everyday Counts 5, Reducing Rural Roadway Departures as well. And so the link for that webinar is that top link. Again, all of these links can be found in the handout in the bottom left-hand corner of the screen if you'd like to download that. Otherwise, you can also find the same PDF once we do post this 3rd part to our Archive Safety Center trainings page. I do also want to remind everyone that Reducing Rural Roadway Departures does have its own website, and it will be getting updated here pretty shortly, so I just want to make sure everyone has that link and that you're aware to keep checking back there for more resources that they're going to start posting soon. And if you do have any additional questions that didn't get answered on today's webinar, you can find the email addresses for both of our speakers on your screen right now, as well as the contact information for the Safety Center. So again, thank you all for joining us today, and Keith and Dick, thank you very much for taking the time to present again. Everybody have a great day. Thank you.